Welcome to this puzzle session. The puzzle we are looking at today is the following. So we have three grasshoppers which stand along a line. So it could be like A, B, C, three grasshoppers. And at each turn, one grasshopper leaps over another, but not over two others. So what does that mean? It means suppose we have the grasshopper standing like this, A, B, C. Then A can leap over B. So when I say one grasshopper, I mean exactly one grasshopper. So suppose A is the one who is leaping. So then A can leap over B. So one can reach from ABC, one can go to BAC. So A has leapt over B, so we'll get BAC, but one cannot get BCA because then A is leaping over two grasshoppers. So this is not allowed, this kind of jumping. Similarly, if B was doing the leaping, then B could leap over A, then in that case we will get BAC, and if B leaps over C, then we will get ACB, and both are fine because B is leaping over exactly one grasshopper. So one way to state it would have been that each turn exactly one grasshopper leaps over exactly one grasshopper. That is one way to say it. So basically this is what is happening. Or C could have done the leaping, and one can write down what are the possibilities there. In fact, there's only one possibility. If C leaps, then C has to leap over B. The question that we are looking at is the following, that after can the grasshoppers return to their initial configuration after, say, these many steps, 1991 leaps, 1991 steps. Is that possible? So it's not clear at the outset as to what to say, but here is how we'll approach the problem. So we have listed out all the 6 possible configurations of the grasshoppers: ABC, BCA, CAB, so on. There are only 6 possible configurations. And suppose this is the current configuration, and then we are asking what could be the next configuration. If this is the current configuration, what are the possibilities for the next configuration? So if this is the current configuration, then A could leap. If A leaps, then it has to leap over B, in which case we will get BAC as the resulting configuration. Okay. If B does the leaping, then B can leap over A. So we can get BAC, or it can leap over C, in which case we will get ACB. So these are the 2 possibilities. And if C leaps, then you will see that you'll get ACB, which is this. So these are the only 2 possibilities for the next configuration if the current configuration is ABC. Similarly for BCA, if we figure that out, we will get CBA as one and BAC as one. So these are the 2 possibilities for this. If we figure that out for CAB, then one can reach ACB, and one can also reach CBA. So we see that from any configuration on the top, we can only get to a configuration at the bottom. We cannot remain on this file. And similarly, if we just compute the same thing for the bottom ones, we'll see that one can only reach the top. So there are 2 possibilities from here, which are some 2 possibilities we have to calculate, some 2 possibilities here, some 2 possibilities here. But the upshot is that you can only go up from any of the 3 on the bottom. All right. So what's the point? Now the point is, suppose after 1991 steps, so suppose we are talking about an odd number of steps. So after the first step, suppose this is your starting configuration, this is the initial configuration. Then after the first step, you will be at the bottom somewhere. After the second step, you'll be at the top somewhere. Now at the third step, you'll be at the bottom somewhere, and so on. So this kind of keeps flipping. So after an odd number of steps, one has to be at the bottom, provided one starts at this. Right? So after an odd number of steps, one cannot reach the starting configuration, and therefore in particular, you cannot reach the starting configuration after 1991 leaps. So that's the answer. The answer is no, for this very simple reason, that if you're at the top, then you'll reach the bottom, and if you're at the bottom, then you'll reach the top in one step. So that's it. And this is the special case of a general idea called the sign of a permutation, which is usually covered in a group theory course. And I did not get into it because I wanted to keep it as simple as possible. Anyway, so I hope you like this problem session. And as usual, like, comment, share, subscribe. I also have Patreon. The link is in the description below. Thank you for listening, and I'll see you next time.